Here's the scheme 1 evaluator. Here's the read eval print loop. The crucial part is this line right here that says print of eval 1 of read. Eval is called eval 1 and apply is called apply 1 in this scheme 1 interpreter. Again, because STK has primitive procedures eval and apply that we don't want to clobber. Okay? When you read this code, which you should do, it talks a lot about how this all works. So it says right here the thing that I said about 4 kinds of expressions. It says the value of a self-evaluating thing is the value itself. Then it says something a little interesting. Unlike real scheme, an STK procedure is here considered a constant expression. That's a little weird, because you can't type in a procedure. But one of the ways in which we cheat in this interpreter is we take all the procedures that STK knows about and treat them as our primitives. So STK primitives are scheme 1 primitives, and also things that you defined in STK are scheme 1 primitives. And as the comment says, because of the way that plays out, when we look at a symbol that's a global variable, we find the value associated with it. It's a procedure. We end up evaluating the procedure. So we just treat that as self-evaluating. Even though you can't type in a procedure, it's sometimes in a recursive call we're going to want to eval a procedure. So that's that. It's a little bit of a kludge. So in the substitution model, we only see global variables, not local ones. In this evaluator, there is no define. And so the only global symbols are the ones that name primitive procedures. Since that's true, instead of actually building a symbol table where we can walk through looking for a name and find the value associated with it, we just cheat and ask STK for the value of symbols. You'll see that in just a moment. Quote is a special form. If is a special form. In this evaluator, not in the real scheme, but in this evaluator, the value of a lambda expression is the expression itself. So we use lambda expressions as the abstract data type to represent non-primitive procedures. Why is that? Well, what do we need to know from a procedure? We need to know the formal parameters and the body. And those things are in the lambda expression. So I'm just going to take the lambda expression itself and say that's the procedure. Okay? And again, all this stuff I'm going over very quickly.